Hi guys, my name is Peter and today I'm doing the Glow Tron material tutorial. And as the result, you will have this kind of nice material. And let me show you some of the functionality. You can manipulate the color state, you can change it to different colors. So it may be basically any RGB color in this range. And it will change, let me see, it will change dynamically as you manipulate, of course, because this is a material instance. And if you want to, you can keep it switching the color. So if I switch the runtime, it will do it. Then, of course, you have metal rough specularity manipulators here, and this is the sharpen power. It works with the input base gradient texture, and you can basically adjust it to get the result that you would like most. And there are plenty of different ways how you can actually keep these parameters to have the big stripes, large stripes, or smaller stripes, and different objects may require different parameter values. So if we go back to the level, let's wait until it loads. Yeah, now it loaded. I showed this in previous video, but this level is created entirely, except for this text, entirely from the material that we will be working with today. So as you can see, you can use the material for level objects, you can use it for environments, and it is fully emissive, so it doesn't require any lights. But if you have ones, then the lights will be reflected very nicely if you just manipulate the roughness of the material. So let's keep going. Let's go to the materials here and go somewhere here, wherever you want, and create a new material. And we will call it Tron Glow, or even simple Tron Glow, because this is a pretty simple material. Open up Material Editor, and first thing is really the obvious one. You just go, you hold one, click, and you get this constant, which is basically a black color for now, for the base color. Because really our material doesn't use any base which is diffuse color at all. It uses emissive color to get very nice glow. And let's start from here. So first of all, we will need a texture parameter. Texture sample parameter 2D is the name. Let's call it gradient or stripe texture. And you can use your own high definition texture, for example 2K or 4K resolution, but I found out that you can achieve really high quality results like this even using the really low definition gradient texture, which is provided by Epic, this one. And as you can see, it's 64 by 256 resolution, so basically it's like really low resolution texture. So you click it here, then you go here and you click here, and this will be the default texture. And yeah, this texture is good enough. So if we start previewing, let's preview the box. It will look like this now. Now what we will need to do is that, as we want it to be on all the edges. So basically we take it, we copy it 4 times, we linearly interpolate between them, and we make sure that each of them covers one side. So to make them turn, we need a rotator. Let's take it, and in rotator let's set the speed for 1, and the rotator operates in the radians. So if I take here in the time, which basically means how much time passed since we started the rotation, if we put here pi value, whoops, sorry, the speed should be 0, I guess. or should it be? Let's see. So it wouldn't rotate in real time, would it? Or not? Let me see. So if we put here 0.5, and I put this guy here, or it should. Why is it not rotating? Yeah, it doesn't rotate. So, yeah, sorry for that. The thing is, if you put here a bigger value, it goes down. If you put here 1.5, it goes the next edge. So that's what you need basically. With each half of the pie, you get to the next edge. And in this, the first one, we don't need this at all because we can keep it like this. This will be the first edge. Now, come on, keep it there. Yeah, right. So we just don't rotate it at all, right? Because if you, yeah, the problem is that if you don't put the time input, it will be rotating in real time. We don't want it. Okay, so we take this one, and then what we need is we need to put it into some power to make it more sharp. And why? Well, because we need to have a really rough edge. So we will add this parameter. Otherwise, it will be really, we can say, fat stripe. And we want to control this, of course. So let me close the gradients, and then we can add a scalar parameter, right? And this will be the sharpen power. And while I was experimenting, the default would be something like 14 or 15. Let's keep it 15, I guess. Yeah. Let's see the result now. It will be here. Yeah, now the stripe is good. The stripe is more sharp. I'll just go 14. Yeah, well, this is fine. Oh, of course, one thing you will see now is that as this is not a high resolution texture, we have these issues. And there is a way to manage to make it look good, even with a low resolution texture. So we go and we click this, we find a subtract node, and from this we subtract some constant. So we take some of these values out, so we keep, so only this one will be kept. Sorry. And also this will be a constant. So again, we have a scalar parameter constant, and it will be, for example, sharpen subtract. Yeah. And you will see now, if I start to preview this, something like 0.2, for example. Yeah, now it looks better. It's still low resolution, but we will manage to make it look good later. To make it look even better. Now, let's clamp to make sure that we don't have negative values anywhere. So yeah, 0 is minimum and 1 is maximum. Okay, this is the first edge, and we need 4 of these. So yeah, just take this, you say Ctrl-C, Ctrl-V. I don't know why it starts to compile the shaders again. I don't know why. This was an issue some time ago, and it's this issue again, but let's keep it like this. A lot of people have this issue, I've seen it on Answer Hub. But let's hope it will be fixed in the new version, or maybe it already fixed because I have 4.1. Anyway, I will have to wait for it. Yeah, let's start previewing this guy. And wait for the shader compilation. Okay. So if we connect something like 1, yeah, that would be the other edge. Can we make this guy real time? Yeah, we can. Okay, great. So let's play with this a little. 0.5. Yes, this is the next edge. Right, so we keep all of this the same, we use the same constants, and we just linearly interpolate between these two. This is the simplest way of doing it. We say lerp, and the alpha is default 0.5, just what we need. Because all of these edges, they're equal. Now, if we put it into the emissive, and let's stop reviewing this node, shall we? We get 2 of these edges, just perfect. And as you can see, it just goes through the all the shape, all of the mesh. So what's cool about it is that you don't have to use any specific texture mapping, so you just use standard one. On this primitive, which is the box, it works just perfectly. You don't have to map the texture or map the material in any specific way. It will cover all the edges. And as I will show you later, with the BSP geometry, it's also very simple. So no big deal. This material is very useful from the beginning. Okay, so let's see. Control V this again. You had this in buffer. And this time, of course, we want to have something like 1. Again, shader compilation, great. Just perfect. Okay, actually I will not be waiting for it. I will just copy it again. So you will have the finished result. You see, this is the problem. More and more shaders are being compiled. This is really dull bug which is still on the system, even though it was claimed it was fixed some time ago in a version 4.11, I guess. They said it was fixed. But we just lure between these two. And then at the end we just lure between these two. Between the results. And this is emissive. Okay. Now this is our network. It looks big, but even from this distance you can see it's really simple. Let's wait for the compilation. It's not a big deal now. It's only like 100 shaders or something. Okay. So, what's up with this? If it finished the compilation of the shaders, why we don't have the end result very well? Let's see. Stop reviewing this one. It doesn't look like anything. My CPU is loaded, and yeah, you see some issues of the material editor which are not fixed yet. We have everything set up pretty well, but yeah, of course you can save, just the right time to save. Yeah, nothing is working, I would say. Okay, stop reviewing this node. Okay, start reviewing something else, I don't know. Please, make it work. Yeah, let me show you what happens right now. This is what happens. For some reason. And I don't know why. And again we get this dull results. Maybe, of course, I didn't... Yeah, okay, let's see what this looks like. Maybe I've set some constants wrong. But I think I didn't. As far as I remember my network, it was just fine. Yeah, and we don't need this multiplier, of course, because it's 1 anyway. Whoops! Okay. Right, the rotator, yes, sorry. This is my problems time after time. I don't know why it's loading the CPU all this time, anyway. But of course the pi is being rotated, it's not just UV parameter there. So the result goes here, and this goes here. Okay? Sorry for wasting your time on this. I should get more sleep, apparently. Of course, now it will want to compile shaders again. But I would tell you that now everything should be set up pretty right. Let's stop reviewing this. I hope it takes more shaders to compile. Okay. But I would tell you that now you will have just the right glow. Not the glow yet, but this cover on the 4 edges already. And there is some more extra stuff that we will need to do, but if I start doing anything now, this will build up more and more shaders to compile, I would say. This is the thing, this is the problem. So in the meantime, of course, I can try to show you something else. Because this takes hell of a time, actually. And I don't know why. I have no idea. Yeah, I can show you something else. So the thing that I wanted to show you is the fact that here I have some material. This is of this material, by the way. Not the one that we're making, but the one that I showed you, which is the same that we will create here today for this comparison time. So the cool thing is that if you take some kind of geometry here, put it on the level, make it smaller, like 200, 200, 200, yeah. And of course it may be any shape, so let me just make it this size. Now you select matching brush edges, and then what you do is that you just apply this material on it. So for example, the last floor, and you say apply material. Yeah, here it is. Okay, it looks like this, and you would think, oh, the alignment is really bad. What to do? We have to map it somehow. Well, you map it really simple. You map it fit, I guess. Yeah, it's fit. And now you see it just mapped perfectly. So it's really simple. If you have any BSP geometry on your level, it is really simple to use this material. You don't have to really bother. And even if you take the really simplistic shapes that we have here, the box, yeah? We take this box and we take any of these instances, we just put it on the box, and it works just like that. You take other one, just switches color, and it works. Of course, I have different ones for different purposes, different materials with different parameters, but you can use any of them. Of course, there are more complex shapes which bring up some not so simple, let's say, texture mapping issues with this material. These are not issues, of course, but they don't map so perfectly. For example, this one. If we take something smaller, yeah, like this. But even with this thing, you know, you have these edges, and it looks pretty good. And I'm pretty sure you can manipulate with this shape somewhere in the level. And it would be useful. But yeah, we got our texture finished. Sorry, our material compilation finished. Now we have it, and it looks good. But you see that it's not glowing, for example. So let's make it glow, and it's really, really simple. So let's make some other scalar parameter, which would be the emissive strength, we can call it. Yeah. And it will be really high value, actually. Something like, even if you put 50, it may be not enough for us. So we take multiply here. Yeah. And we just multiply it like that. Because this is emissive, it will glow. let's see how much time does it take. Not much. Okay. Now tell me why you're not glowing. Yeah, you do glow. It's just a material compilation. Yeah. So it glows pretty good, and you can even put 90. I have as a default on my older material. Oops, sorry. No, I have 90. 90. Yeah. And this is good enough. Now there are two things left to do. First, let's talk about color, because we really want to manipulate our colors, right? So, aside from this network of nodes, let's build another network. First of all, we need two vector parameters. First one will be positive color. I will show you my way how I compose the material. You can use other, of course. And the other one I would call negative color. And why I use this idea of negative positive colors? Well, because I want to have one constant which will work in such a way that if I put it on positive, it will use one color. When I put it lesser than 0 or negative, it will be other color. If I put it to 0, it will be glowing, switching the color in a real time. And this is, I would say, this is cool enough. So for this color, you can set something like red, of course, or as I would suggest, of course, something more neutral. This as a negative color, well, blue, bluish, or something like this. Really, whatever you want. Hey, why don't you set yourself? Come on. Yeah, okay. They should display. Yeah, they do display. Okay, great. So, how do we do it? Well, first we need a scalar parameter, one more, and it will be a color state. Yeah. And this is the one that will have negative values or positive values. For now, let's put it to positive. And then we will need if. Now, if in shader programming language is really not the cheapest operation, and basically you should try to avoid it as much as possible when you are programming a shader code in HLSL or GLSL. And basically, as we know, this is just a graphical editor for HLSL code. But yeah, so we try to avoid if, but this material is already quite cheap. So it uses one texture, it uses emissive, it doesn't use any diffuse color. So yeah, it's pretty cheap, and we can basically use if for our own purposes for now. Of course, you can try to make it cheaper, you can avoid this functionality altogether. But let's go for it now, because I would like to show you the way how I made it for my game and my project. Because with one material you can make a lot of stuff now. With this material, it's really robust. Now the B parameter will be 0, because we will be comparing this set value to 0. Just this, nothing else. Now, okay. When A is more than B, we take the green one, the positive color, right? This is more than 1. When this is lesser than 1, well, we take this color. But if it's 0, we need this kind of a switching glow, I would say, yeah? So how do we make it? Well, we make a lerp, and as an alpha for lerp, we will use a cosine function from time. So let's take time. Let's take a cosine from time. Now, as we all know, cosine goes from what does it go from? From 0 to 1, I guess, right? Okay. It's been a long time, actually, since I've been using trigonometry in real life, so it may be going from -1 to 1, but I don't remember. I guess it's from 0 to 1. Now, yeah, you should excuse my poor knowledge and poor memory. I was never good at math. So, if a equals b, so if this is a 0, then we're lerping between and then this and this, and time just goes on. This value becomes bigger and bigger, but cosine will be going like that, from 0 to 1, right? And you can test it right now if we just finish it. So what we do is we basically multiply. And what do we multiply? Well, we multiply this before we add the emissive strength. Yeah. So we move this a little bit here. The result of this will be here. We multiply this by f. And let's try to organize this a little more. Yeah. So you can already see how well does it work. Okay. This is good enough. Or this is good enough. So yeah. Now, if this is 1, this is green. You put a -1 value. And it goes blue. Yeah, and now it's 0. And real time. Here you go. And of course you can add extra parameters to manipulate the speed of this. But for me, I just changed the period to 2. The bigger the period, of course, the more time it takes. So this is twice the time. And again, if you put here 0 and you put real time, this is more subtle, more slow glow, and you can manipulate this. So as I said, you can add extra parameters to manipulate the speed of the the switching glow, but this is also up to you. And this is the second thing we had to do. Now the last things are some other minor parameters that we can manipulate for some reason if we would need to, adjust our material for different environments. So this will be metallic, specular, and roughness, just like that. If you want to have a glass floor with this material, something else, or matte, or whatever, you just manipulate this parameter. So let's add 3 scalar parameters. The first will be the metal. The second one will be the spec or specularity. Yeah, and the third one will be, of course, rough. Metallic, specular, and roughness. And as defaults, of course, let's keep them pretty down like this. Even this can be useful, trust me. Even if you would assume that this material would not be metallic ever. For visual effects, this will be pretty useful. Okay, so as you can see, the network is not the smallest one, but the material itself is pretty simple, and I hope that I could explain it to you in this video, and you figured out that it's really pretty simple material. Okay, so let's see, save now. Let's save it. Now it will finish the shader compilation once again. Oh, that's pretty fast. Good. Now, this is our map. This is my Tron map, and here now this is the material, which is where? Simple Tron Glow. Okay, this is it. Yeah, let's test it. Let's put it on this thing, for example. It works. But of course, these are default parameters, right? So let's create a material instance. Of course, typically you would be using it with material instances, this material. And now gets the cool part starts, because now everything you modify, you don't have to wait for the shader compilation. And remember that you can organize these parameters in different groups, just going like here and changing the group. So you just write a new group type or existing group type if you have several groups. And yeah, you can do this in several seconds, no problem. So we can override the color state here to 0 to make it glow in real time, yeah? And of course, you can override the colors. Even when it's switching the color during the glow, you can override it. It's pretty good. And as you will see, Unreal Engine 4 has really good algorithm for bloom. So this bloom works and looks really good with any color, and it's pretty amazing actually. So you can see you can have any kind of colors you want here. Now these are the parameters that you also would like to have a full control of. Because for example for the boxes, I would really want to have really thin lines, and as you can see, this is the way how you can achieve it. You improve the sharpen power, you improve the sharpen subtract. But beware of the I would say it's texture filtering problems. When this gets really thin, you can see this becomes a small problem. And I haven't been looking for a way now how to really fix it, but I'm pretty sure there are some, and we could find it on the forums, we can find it on Answer Hub. But for now this looks great already, and you can work with this material, you can put it anywhere. And I just showed you the way how you can put it on the map, pretty simple, and how you can put it on BSP without any bothering with the texture mapping. So yeah, this is the Tron Glow material. Thank you for watching, and stay tuned for more tutorials to come. Bye bye.